Right, so we're going to start here with oxidation and reduction. And we're going to look at sodium thiosulfate. So we've already done the first part of this chapter, which was potassium permanganate. Potassium permanganate is an oxidizing agent. Sodium thiosulfate is going to be a reducing agent. Okay, so we'll have done one of each then. Its formula is Na2S2O3. The Na2 does not take part in the reaction, so often what you'll just see is this S2O3 2-, and that is what we call the thiosulfate ion. Okay, so when we're looking at equations, that's usually what we'll see. It is a solid and it is crystalline. And it's colourless. Okay, so it's composed of crystals. It has two main uses. The first use is in analytical chemistry, so using to analyze chemical substances. And secondly, it's used in image fixing in developing photographs. So any photograph that you get developed is going to use some bit of sodium thiosulfate. Okay? The biggest thing that we're going to look at now is that it itself is not a primary standard. And remember, we looked at a primary standard before. A standard solution is a solution whose concentration is precisely known. And primary means that it is stable in air, it's sufficiently pure, it undergoes complete and rapid reaction, and it dissolves in water. Sodium thiosulfate is not considered one of those because it is impure. So in order to actually determine its concentration, we are going to have to carry out a titration. And the titration that we carry out is against iodine. But there's a problem here with iodine as well, in that iodine is also not a primary standard. And the reason why it's not a primary standard is because it sublimes at room temperature. And sublimation is when we have the conversion of a solid directly into a gas.